So again, all you're seeing here are answers, and certainly discuss if you would like.
We did? At least you got the first one right. We got the last three right.
No, it would be like, it just be easy.
Okay. Did you plug back into this one? So it should be y equals 4x minus 7. It's because of the typo. 4 minus 7 is -3.
It's like,
It wasn't really that there. It was more paying attention to
this.
I'm doing.
How's it going?
This is UMR 17.
Everybody gets swings on that.
I've never got so much.
Because you don't take heat.
There's only 2 people, really.
That was a low blow. Low blow.
Everyone else is
I'm so hot, but I hate it. I'm wearing a sweatshirt long sleeve. Yeah, when I was shooting.
Hey guys, questions on 1 through 4? What can I do to help? Anything? Hey, let's do a little comparison. I think this would be a healthy comparison. Do you guys remember earlier this week on Monday, I think it must have been, showed you the same sort of set of questions here, and it was a major struggle, wasn't it? Like 15 minutes later, most everyone was not done with at least one of them, and like everybody was like, oh, I'm really, really struggling. The struggle bus. Are you doing better? Have you gotten off the struggle bus? No. Or maybe you're making your way off the struggle bus. You're moving towards the front or something, whatever the analogy is. Guys, really, are there any questions at all? Sure. So number 3, listen, number 3 is always a challenge because, listen, I get it as a math student. When you get a paragraph like that, we just want to, kind of go off the struggle bus. We just want the easy button, don't we? And I got to tell you, I do not think that the best way to approach 3 is with some kind of an easy button. Number one, because there really isn't one. We can go find some cutesy way of doing it. We could do a graphic organizer. We can do this or that. We can have this little phrase that we remember, whatever. I don't think that serves you well because any of those cutesy things, eventually you're going to forget them and it's going to be sort of pointless. I would rather help you be a problem solver versus I memorized some steps that I may or may not ever remember again. So I'm thinking this, here's my approach. If you're faced with some word question like this and you don't know what to do, step 1, I'll give you some steps. Step 1 is try to draw a picture. They say a picture is worth 1,000 words, and I think that a picture would be potentially very helpful here. Here's what my picture looks like. It's not very fancy. I can tell by reading this thing that both of these boats start off in Miami. There we go. And they travel south. So for me on a map, south is downward. So I'm going to say that the cruise ship started right there in Miami and it went down that way. I'm going to call that distance of cruise ship. I'm just drawing a picture of my little story here. And then I also know that the fishing boat started in Miami as well, in the same place, and also went south, and very importantly, caught up to the cruise ship. So obviously, the fishing boat is going faster than the cruise ship, right? That one's pretty obvious. I'm just going to draw a picture. Does my picture make sense? Is it a nice, let me put it like this. Is the picture a really nice low floor? I feel like anybody who's having a good day could read this and draw a picture like that. That make sense? Now, can you do the steps to follow? Maybe, maybe not. I don't know. Hope you can. But this is a pretty low floor. I want you to come in here and say, all right, I can draw a picture of that thing. The next piece is definitely a step up. We need to start translating this into math, not just like pictures and stories and fishing boats. We need to get this into a math scenario. And for this, we need an equation. We need a relationship. So how do these two distances relate to one another? The distance of the cruise ship and the distance of the fishing boat are the same. They're equal, aren't they? Didn't they both start in Miami? And they both finished out there in the ocean somewhere at the same spot? Because the fishing boat caught up. So I would say distance of cruise ship equals distance of fishing boat. Got to get a little more mathy here and then we'll be done. We got to remember that distance is the same thing as rate times time. So I got to think of the rate of the cruise ship, and if I read this carefully, I can actually see that the rate of the cruise ship is the thing I'm trying to find. So I don't know what that is. So I'm going to put RC for rate of cruise ship. What was the time of the cruise ship? How long did the cruise ship go? Yeah, started at noon, stopped at 5. 5 hours makes sense. And then the fishing boat has its own rate and time. What was the rate of the fishing boat? 10, it's right there. And the time that the fishing boat was traveling.
4 hours.
Started at,
1.
ended at 5. Sounds like 4 hours to me. Does that make sense? We've obviously converted this over from just being a picture and a story. Now we're fully into the math, right? To finish this one off, I would divide both sides by 5. RC is equal to 8 miles per hour. So our initial suspicion that the cruise ship was slower than the fishing boat appears to be true. 8 versus 10. So let me give you some thoughts about this, Kyrie. If you draw a picture or not, I'm not going to take points off your quiz. Draw the picture or don't. Am I even going to take points off if you don't write that? I don't think so. You don't really have to have that. What do you really have to have? You really got to have the stuff in purple. You got to have, basically for this one, it'd be RT equals RT. Little algebra, answer. And if you're a master of this, I would expect you to do something just like that. If you're not a master, I would expect that you're drawing pictures and you're underlining your work, or underlining your words in there and showing maybe a few additional steps. Not because my teacher's going to inspect my steps, but more in the spirit of, I kind of need to do it this way so that I can make sense of it versus memorizing a bunch of junk that I don't really get. So try to approach it from a problem solver standpoint, not a, just tell me the steps. You can all come up with steps, but I don't know. They usually don't stick that well. We done? Joe?
We had time today to go over a couple questions on the review.
I wish I did, but that was yesterday, and I only got 35 minutes, and I got to somehow get some stuff done. Because, as you know, as I say all the time. Number 2, okay, so here, again, I'll try to illustrate this. This is so important for you to get, because percent is all over the place. You might argue that percent is the most important thing you could take out of algebra. Because I doubt you could go a whole day and watch the news or listen to the radio or go about your business in the world and not hear about some kind of a percent, right? It's everywhere. So, Callie, let me ask you a question. I think I maybe asked the other class this question. I'll ask you guys this question. You guys have your test on Monday, right? So then on Tuesday, Lord willing, I'll hand the test back to you. Let's say I hand the test back to you. Callie, here's your test. And at the top, you see 44. What's your reaction?
Well, it depends on what it's out of.
Oh, doesn't it? What might the 44 mean?
Like 44,
It could be 44%,
or like 44 out of 50.
or it could be 44 out of 50, both of which have radically different meanings, don't they? One of them, she's like, all right, 44 out of 50. She's hoping for an A, but that's not terrible. 44%, she's like, what did I do wrong? Because that's about the worst I would have ever expected to get, right? Very different reactions, right? So when I look at number 2, basketball team scoring average last year was 37.2. This year, the scoring average is 41.7. What was the percent of increase of the scoring average? Well, in order to know what that is, I need to know by how much the scoring average went up. So what operation do I use to find out by how much the scoring average went up? That's right. That's how you find the difference between two things. So it'd be 41.7 minus 37.2, and that's got to be what, 4.5? Yeah? Yeah, 4.5. Okay, so if I were to stop right there and say, oh, their scoring average went up 4.5%. I'm wrong, aren't I? 4.5 is not a percent. It's simply the raw number of points that their scoring average went up. So that would be like me mixing up the 44 out of 50 versus 44%. Very, very different. So the way that I actually figure out what kind of a percent increase that is I've got to compare it to what the scoring average was before. Here's one way of doing that. Part equals percent times the whole thing. So the part would be 4.5. The percent is my unknown. The whole thing I'm comparing to what it used to be. So it used to be 37.2. And then to solve this, I just solve it like a regular old equation. Divide by 37.2. And convert it to a percent. It's like what, 12%? 12.1%. I think you get like 1.1209.
1209.
Yeah, so you convert that over to a percent, you get 12.09, which is 12.1 if you round to the 10th place. Does that make sense? Okay. Like I said, I think you could successfully argue that dealing with percent is the most important takeaway from this class. I'm glad you asked. All right, so let's do a little bit of fact, Joe.
I did, for that one, I did 41.7 divided by 37.2 and got
Yeah.
a really similar.
You know, you should have gotten 112.1%. So what that means is you took the whole thing, 37.2, and you added something to it. You added 12.1%. You could actually do it that way as well. You just have to subtract the 100% out. Because with that, you're including the 37.2 that it used to be. If you subtract that out, you're left with 12.1%. Yep. Okay, let's do some factoring here. We'll be able to do one or two of these. I think you'll find the process for these to be the same as before. So we'll get to like maybe 2 or 3 of these. We'll see. Okay, so let's review. Can anybody explain or define or give an example of a quadratic? What's a quadratic? Other than a scary word you hear in math class. Come on. That's what we did yesterday. That is a quadratic. Well done. And that's the most generic version, right? The A and the B and the C are just numbers. The A and the B and the C standing for whatever numbers they could be. So can anybody give me an example of a specific quadratic, not with A's, B's, and C's? What could that look like? Joe.
4x squared plus bx, plus 6x plus 14.
Can I make it minus 14 just for sake of argument? Okay. So if we go with Joe's quadratic, what's the A value?
4.
A is 4. What's the B value?
6.
And what's the C?
Negative 14.
It's got to be negative 14. The sign in front of the number is part of the number. for this purpose. Okay, so yesterday we focused on quadratics where the a value was always 1. Today we're going to focus on what do we do if a isn't 1. The short answer to that question of the what do we do if a isn't 1, nothing really different. We do it the same way we did it yesterday. That's why we did it the way we did it yesterday, so that it would be consistent. So I thought I'd review this with you. I'll do one of these here, and maybe we'll have you guys do the second one. So please write with me, watch, ask questions if any of this doesn't make sense. If you all remember, the way that we set this up is we build ourselves a 2x2 box. So there's my box, and now it's 2x2. What do I always put in the upper left-hand corner?
Your a squared.
Yep. So in this case, it's 2x squared. What do I always put in the lower right-hand box? The c value. Yep, so that's a 5. And it's those other two boxes that we are always going to have to do a little bit of work to get. Okay? So do you remember? Or do you have a question?
I remember.
What do we do?
Don't we multiply the first number by the last one?
So in this case, it would be what times what?
2 times 5.
Yep, you do a times c, which is 2 times 5. You're right.
So then 10 is what we use to, I guess, like find these two numbers that I'm going in the box. It's like we're multiplying them.
That's right. So we got to think of all the numbers that multiply to be 10. I got that from multiplying the a times the c. So let's list them out. What times what is 10?
5 and 2.
5 times 2. What else?
Negative 5 and 2.
You got it? And there's only one more set, right? 10s and 1s. So 10 times 1, negative 10 times negative 1. And one of these pairs should work, right? So what we're now checking is which of these pairs, we know that they all multiply to be 10. The question is going to be which one adds to be my b. So which pair adds up to be my b? 10 and 1, right? This adds up to be 7, adds up to be negative 7, negative 11. Those two add up to actually be 11. So it doesn't matter the order in which I do this. I'll just put the 10x here and the 1x there. But I could have swapped those, and it wouldn't really, in the end, make any difference how I did this. And then the finishing is just to factor out the common factor. So if I factor from right to left up there, what's in common? There's a 2, right? Because 10 is 2 times 5. And there's also an x. So I'd say 2x. What's my common factor there?
1.
Just a 1. Yep. 1 goes into 1 and 1 goes into 5. So that's good. What is my common factor here? Just an x. And how about there? 5. Yep, 5 goes into both 10 and 5. Okay, so then my final factoring would be 2x plus 1 times x plus 5. You see how that's exactly the same as yesterday? Except in this case, the a was not 1. But the process, exactly the same. I'll leave that up there if you guys would take a couple of minutes here. This will time out nicely. Would you guys try number 2? Try number 2. Give you a couple minutes to work through it, and then we'll finish together. You do. Don't pack up right now. It's a quadratic, so we need a 2x2 box. So there is my box. And now it's 2x2. I always put my lead term here, and I put my c there, right? It's always the same. Off to the side, AC is negative 42. And I try to think of all the numbers that multiply to be negative 42. Maybe I start off with this one. Negative 6 times 7, that works, but it doesn't add up to be 19, does it? So I'm thinking to myself, maybe I'm proud of myself. I come up with this one, negative 3 times 14. That's a tough one, right? But when you add those up, you get 11. I'm getting closer, aren't I? So maybe I try this one. Maybe I eventually get to like, oh, you know what? 2 times negative 21. Well, that adds up. Oh, it's so close, right? It's negative 19. So this is actually a pretty easy switch. I want negative 2 times positive 21. That actually works. And so I don't know how long that process takes you, but I will tell you if it takes you a long time now, if you keep working at it, it will take less time later. So don't shortcut that, all right? So then negative 2x could go here, and 21x could go there. And then I just factor as normal. So what's in common there? Looks like a 2x to me. Do you see it?
What is it?
Nope, because it's based on the finishing box. Going from right to left, the finishing box is positive. Going from right to left, the finishing box is positive. What's in common? 7. 7 goes into 21 and 7. Now this is where we're going to get a negative. When I factor up here, what's in common? A 1, but the finishing box was negative, so it's going to be minus 1. Factoring up this way, what goes into both 6 and 21? 3 does, and there's an x. That's right. So it'd be 3x. So your factoring, your complete factoring would be 2x plus 7 times 3x minus 1. We need to practice that some more. We will be doing that on Tuesday of next week. Have a wonderful day. See you guys.
I got